Hi everybody, week 6. How crazy is that? Okay, week 6 lesson, attributes of exponential function. So this is going to be very important for you to know. The parent function of exponential function is f of x equals to a times b to the power of x. We all know that another name for f of x is y. So I'm going to write it down here as just y equals a times b to the power of x. So a couple of key components you need to know about the parent function of exponential functions is a, the value of a will never equal to 0. So you will never have 0 as the number for a. The value for b is greater than 0. Another thing about b is it will never equal to 1. Here's an example of exponential functions. There's two types. There's a growth and there's a decay. So growth is an increasing graph from left to right. Decay is a decreasing graph from left to right. So to find a y-intercept of an exponential function, it's very easy. It's always 0, comma, and whatever the value of a is in the function. So if a is 1, then it's 0, comma 1. If the a is 5, then it's 0, comma 5. If a is 0.3, then it's 0, comma 0.3. You just have to plug in the value of a. For domain, it's always going to be all real numbers. So remember, domain is x, right? And it's always left to right. So if you follow the graph to left, it's going to continue on to the negative infinities. And if you follow it to the right, it's going to continue on to the positive infinities. So we call that all real numbers, which we can also write down as a negative infinity to positive infinity. The range of an exponential function will be y is greater than 0, which means that the graph will stay within the positive sides of our coordinate plane. The reason it's not equal to 0 is because of our horizontal asymptote. So horizontal asymptote, just asymptote in general, it's a line that our graph will never touch. It will never cross. If we zoomed it in really close, you will see that our graph will never actually touch, even though it may look like it from far away. So how can you tell if our graph is going to be an exponential growth or exponential decay without a picture? So it's going to be determined by our variables a and b. So when a is greater than 0 and b is greater than 1, that is an example of growth. So what does that mean? So a is greater than 0, 3. B is greater than 1, 2. That is an example of exponential growth. What about for exponential decay? A is greater than 0, 3, and B is a number between 0 and 1. So any number between 0 and 1, 0.7. That is an example of exponential decay. For example, what if you got y equals 0.4 times 1.6 to the power of x. 0.4 is going to be the a value. 1.6 is the b value. The b is what determines growth or decay. So 1.6, that is greater than 1. So when your b value is greater than 1, that's going to be your growth. So this is an example of exponential growth. What if you had 0.4 times 0.79 to the power of x? That's your a, that's your b. 0.79 is not greater than 1. This is actually between 0 and 1. So when your b value is between 0 and 1, that is going to be decay. So this is an example of exponential decay. The next section of the first page, we're going to skip it for now and come back to it later. If you move on to page 2, this section here will help you complete assignment number 1. For assignment number 1, what we're going to do is look at two exponential functions, y equals 3 to the power of x and y equals y to the power of x as an example, and we're going to compare their graphs, domain, range, y-intercept, and asymptotes. So we start off with the first function, y equals 3 to the power of x. What we did was created a table of values. So we chose any x values to plug in. You don't have to use these specific numbers, but we just use the easiest ones. And all you do is plug them into the function. So wherever you see the x in the function, that's where you plug them in. And when you calculate it, it's going to give you your y value. And so what that does is our x and the y value will give us a point that we can plot on the coordinate plane. So x equals -4, plug in -4 where you see the x, and we're going to calculate this. I know you guys don't have a calculator that will help you do the exponent, so what I'm going to do is have you guys use a website called Desmos. So desmos.com is basically an online calculator. So I was going to put online calculator, desmos.com. You're going to get this website. So if you look down here, you have two options. There's a for function and a scientific. For function calculator is what you're used to using in class, the one that's really limited. If you click on the scientific one, this one lets you do a lot more. So we're going to use the scientific, and we're going to calculate this one, 3 to the power of -4. So 3. There is this exponent button, but if you notice, it's already set to 2. So if you click on that, the exponent automatically becomes 2. So we don't want to use that one. Instead, let's use this button right here with the b. So when the exponent is the variable b, just basically saying you can put any value for the exponent. So -4. So without having to click on the enter button, it already gives me the answer. And if you look at the notes, that's how we got the y value as 0.0123. On the calculator, if you click on this button, it converts the decimal into a fraction, and then you can click it again to convert it back to the decimal. So that's pretty useful. So that's basically what we did here. We just plugged in these x values into the function, we calculated it to get our y values, and the x and the y values create points that we can plot on the coordinate plane. When we connect those dots, that's how we get our graph. But we're not going to do that. We're actually going to use Desmos to just graph the function. So what I'm going to do is open up a second Desmos window. And so I can keep this window to use the calculator, and I can use this window for graphing. If you click on the top right button here, it says start graphing. So I'm going to just type in my first function, which is y equals 3. Shift number 6. That's going to help us type in our exponent, and then click on x. And there's our first function, y equals 3 to the power of x. You can use this window to hide that little list, and there is our graph. So let's quickly describe this graph. So this is an example of exponential growth. It is increasing from left to right. Our domain is all real numbers, because if I follow it to the left, it will continue on towards negative infinity. And if I follow it to the right, even though it is going up, every single point has an x value, and the x values will increase. So right here, it's 0.39. Right here is 0.99. 1.47. It is increasing. So following it to the right, it is increasing towards a positive infinity. So it's all real numbers. The range is up and down. If I follow it up, it goes up towards the positive infinities, but if I follow it down, it actually does not reach the negative side, and that is because there is something on this graph that's making this graph turn instead of continuing to go down. And it looks like it's touching 0, but what I'm going to do is actually zoom in. And when you zoom in, you can notice that it actually doesn't touch 0. So let me find another area that looks like it's touching 0. But when you zoom in, zoom in as much as you need to, it does not actually touch the x-axis. So that's pretty cool. So for our range, we can conclude that it's y is greater than 0. Now for the y-intercept. It's easy to look at the y-intercept when you have a graph. It's right here, and if you click on it, it will tell you the point, 0, 1. But what if you didn't have a graph to look at? How can you tell? So let me go back to my notepad. So the function was y equals 3 to the power of x, right? and our function is written as a times b to the power of x. First, let's figure out which values represents a, which value represents b. This 3, it's attached to x. So we can safely say that the 3 represents b. So then where is a, right? Where is a? If you don't see a value that could represent a, you're going to use invisible 1. The y-intercept is written as 0, a. So if a is invisible 1, it's just 0, 1, and that's where your y-intercept will be. So if a was 2, then it's 0, 2, and a is 5, 0, 5. Just like how we kind of went over in the beginning of the lesson, you just use the value of a to find the y-intercept. So that's how we get 0, 1. So that's basically what's stated here. The domain of y equals 3 to the power of x is all real numbers, or negative infinity to positive infinity. The range is y is greater than 0, or 0 to positive infinity. Your y-intercept is at 0, 1, and your horizontal asymptote is at y equals 0. Now we're going to look at function 2, which is y equals 8 to the power of x. We're doing the same thing, just like the first function. We're going to plug in these x values to the function and calculate the y. And the x and the y gets us our points that we can plot and connect to create this graph. We're going to just graph it here on Desmos. Y equals 8, shift 6, x. And that's how you get your second graph. If you notice, it's color-coded, so you can tell which graph represents which function. Okay, so let's look at the blue graph and describe it really quickly. It is an exponential growth because it's increasing from left to right. Our domain is all real numbers as it reaches negative infinity and goes all the way up to the positive infinities, right? Our x values increase. Our range is also y is greater than 0 because it will never touch 0. That's where our horizontal asymptote is. So the range is y is greater than 0, and our horizontal asymptote is y equals 0. Our y-intercept, just by looking at the graph, is also at 0, 1. But if we didn't have the graph, let's take a look at our function, which is y equals 8 to the power of x. Again, it's written as a times b to the power of x. And we can say that 8 to the power of x is b to the power of x. So where is a? If you don't see a, it's invisible 1. And you write the y-intercept as 0, a. So it's 0, 1. What we're trying to do is compare the two. So here we have 3 points. Both graphs are increasing, but y equals 8 to the power of x is increasing more rapidly than y equals 3 to the power of x. You can see that using the decimals. So the blue, right, that is increasing more rapidly than the red. Second point, both graphs have a y-intercept of 0.1, which was true, and no x-intercept. There are no x-intercept because these two graphs will never touch the x-axis or cross over. The third point, since the graphs approach the x-axis, approach means it gets close to it but actually doesn't touch. So since the graphs approach the x-axis, y equals 0 is a horizontal asymptote for both graphs, which is true. So now let's look at our first assignment. I'm going to do number 2 for you. So we have our two functions, y equals 1/2 to the power of x and y equals 4 to the power of x. I'm actually going to change the names of these functions. Keeping them both y equals and y equals, it just gets too much work for me to refer to one or the other. So I'm going to change it to f of x and g of x. Remember, function notations, f of x, g of x, k of x, m of x, those are all different ways to name functions, so it's easier for you to refer back and forth from one to the other. So what I'm going to do first with it is create a table. Now, just to make this easier, I'm just going to use 5 x values, -2, -1, 0, +1, +2. And I'm going to plug it into the function and calculate it. So you can use decimals for that. You can again click on this button for the exponent, or you can do shift number 6. What was it? -2. And it tells me it's 4. When exponent is -1, I'm just going to change that, it's 2. Anything to the power of 0 is 1. Anything to the power of 1 is itself. 2 is 0.25. I'm actually going to keep it as a fraction, so 1/4. And I'm going to do the same thing to our g of x. And use the same x values. Four to the power of -2. And I'm going to keep it as a decimal this time. 0.0625. 4 to the power of -1. 0.25. Anything to the power of 0 is 1. Anything to the power of 1 is itself. And 4 squared, 4 times 4 is 16. So our x and y values that we get from the table, they create points that we can plot on the coordinate plane, and you can connect those points to create your graph. But without having to do that, I can already tell if this is going to be a growth or decay. How? Look at your x and y values. Your x value, it increases. Your y values, it decreases. So when your x values increase, your y values decrease, and you get an exponential decay. Now let's look at g of x. When your x values increase, your y values increase. And that's how you get exponential growth. So f of x is an example of exponential decay. X values increase, y values decrease, and g of x is an example of exponential growth. Your x and y both increase. But just to make sure, let's graph it on Desmos. Okay, I'm going to delete all this. And we had 1/2 to the power of x, 4 to the power of x. There you go. Decay, growth. Now all you're going to do is just describe the comparison. And we're just going to make it very simple. So f of x, we know, is an exponential decay. G of x, we know it was exponential growth. Now look at the instructions. They want us to compare the domain. Okay, domain. Domain is left and right. So if you look at the left and right of both graphs, they continue on to the infinity. So domain is all real numbers for both graphs. Range. Range is up and down. So if I look going up with the graph, it continues on. If I go down with the graph, it stops. It doesn't go into the negatives. So, and if you refer back to the notes in the first page, your range is y is greater than 0 for both graphs. Next is they want the horizontal asymptote. Same thing. If you refer back to the first page, you'll see it. But also if you look at the graph, our two functions will not cross the x-axis. And like I had shown you guys before, zoomed in, our graphs will never actually touch 0, right? It will never actually touch 0 or the x-axis. So that's because our horizontal asymptote is there. So our horizontal asymptote is at y equals 0 for both graphs. Okay, what about the y-intercept? Well, if you look at the graph, it's clearly shown here. It's at 0, 1. But I need to explain how you can find that without the graphs. To find the y-intercept of an exponential function, you have to look at the a. So it was written out as y equals a times b to the power of x. Now let's look at f of x. F of x was just 1/2 to the power of x. Compare the two. What do you think the 1/2 represents? Well, it represents b because it's attached to that exponent. So, well, where's a? Remember, if you don't have a, you're going to use invisible 1. So if your y-intercept is 0, a, and your a is 1, your y-intercept is at 0, 1. What about your g of x? Our g of x was 4 to the power of x. Same thing. If you compare the two, the 4 is the b, and if you don't have a, you use invisible 1. That's how you get 0, 1 as the y-intercept. And that's all you have to do is just compare and state the obvious and move on. Okay, let's move on to the next section in our notes. So this section on page 3 is going to help you do assignment number 2. So for assignment number 2, all you have to do is identify if a function is exponential growth or decay, and also find the y-intercept. So here, remember, we write it as y equals a times b to the power of x. That's the model for exponential function. And the examples that we have is y equals 2 times 0.3 to the power of x. You can clearly see which value represents a and which value represents b. Now, all you have to do is, for assignment number 2, is figure out if this is an exponential growth or decay. You look at the b value to tell you that. The b value here is 0.3. That value is between 0 and 1. Since b is between 0 and 1, the function represents an exponential decay. Now, next you have to find the y-intercept. Remember, y-intercept is just 0, a. The y-intercept is 0, a, so it's 0, 2, because 2 represents a. Please don't get confused with using 0.3 as a. That is b. Okay, a is here for 2 and 0.3 is b. Next example, y equals 0.33 times 4 to the power of x. What determines if it's growth or decay? The b value, the number inside the parentheses. That number is clearly greater than 1. So when b is greater than 1, the function represents exponential growth. What about the y-intercept? 0, a. So a is 0.33, so the y-intercept for this example is 0, 0.33. When you have a word problem, this is where I want you to refer back to this section that we skipped in the beginning. So for this model, I color-coded everything so it's easier to understand. The a represents a total amount. So this is what you're going to get after you calculate everything else. The little lowercase a, colored green, that is going to represent the initial amount in the word problem, starting point, but that's also going to represent the y-intercept. So if it ever asks you for the y-intercept, that's going to be the little lowercase a. The r, that's going to represent growth or decay. So if r is greater than 0, it's going to be growth. And if r is less than 0, it's going to be decay. Okay, so whatever number you get inside the parentheses, greater than 0 is growth, less than 0 is decay. And the t represents time. So for example, if they say 10 years, then t is going to be 10. 5 seconds, it's going to be 5. Here's one key point. If r is given to you as a percent, you have to convert it into a decimal. Okay, you will never use r as a percent. You will use it as a decimal. So like how we practiced in the beginning of the lesson, always convert the percentage into a decimal. All right, so let's give it a shot. And I'm going to do number 1. Identify if the following functions are exponential growth, decay, and find the y-intercept. Okay, so we have y equals 2 times 1/3 to the power of x. Okay, this one I want you to use for word problems. Okay, this one I want you to use just the y equals 8 times b to the power of x. Alright, so just like the notes. What determines growth or decay? B value. So our B is 1/3. If you don't know what 1/3 is, just use decimals. Perfectly fine. 1/3. 0.33333. So I'm going to just switch this out. Okay, so 0.33, that is a value between 0 and 1. Again, just refer back to your notes. When it's between 0 and 1, that is going to be decay. And now all we have to do is find the y-intercept. Y-intercept is 0, a. Where is a in this example? Or what value is a? 2. So our y-intercept for this is 0, 2. So on the Word document, you just have to type it out. This function is an exponential decay because our b value is between 0 and 1. Or you can actually type out your reasoning. This function is an exponential decay because the b value is between 0 and 1. And that's perfectly fine. The y-intercept is at 0, 2. And that's it. All right, now let's look at our last assignment, number 3, but let's look at the notes. For assignment number 3, you're going to be working with word problems. And so here's the example. You have invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? So your goal is to answer this question. So we're going to use this model to use with word problems. And again, I color-coded everything so it's clear to understand. A, this represents a total. So this basically helps you answer the final question. This little lowercase a color green is the initial amount, the starting point, your y-intercept. So going back to your word problem, what was your initial amount? What did you start with? You have invested $1,000 in a savings account. So that is your initial amount. So your A is 1,000. And right here I wrote A is equal to 1,000 because it's the initial amount, the starting point. Next, 1 plus stays the same. R, that is your rate. That's going to determine if it's growth or decay. So which part of the word problem tells you if it's growth or decay? This 5%. The account pays 5%. The account's going to pay you. So if something's paying you, you're earning, you're gaining that money. So that is growth, right? And remember, the key point is if the R is ever a percentage, you have to convert it into a decimal. So the 5% converted into a decimal is 0.05. So if you look at R equals 0.05 because that is the growth. Turn 5% of annual interest into decimal. Okay, moving on. The T represents time. So if you continue with the word problem, how much money will be in the account after 6 years? That's a question. So they want to know what happens in 6 years. So T is going to equal 6, and it says it here, T equals 6 because it's the amount of time, 6 years. All you do after that is you plug in all of those values, those information. So total equals 1,000 times 1 plus 0.05 to the power of 6. You just do the math. 1,000 times 1 plus 0.05 is 1.05. And you just calculate that on decimals. You just have to plug everything in. 1,000 times 1.05 to the power of 6. And that's how you get to the power of 6, 1340.09, but they rounded up to 0.10. So what does that mean? What this means is after 6 years, so this T just represents time, remember? So after 6 years, you're going to have $1,340.10 in your account. This extra $340.10, that was just given to you, paid by the bank because of interest. I hope that makes sense. So it says A represents total or the result, so the account contains $1,340.10 after 6 years. I'm going to do number 1. And this is the model that I'm going to use for word problems. You invested $500 in a savings account. The account pays 3.5% interest. How much money will be in the account after 5 years? So let's start here. Remember, this A represents total, and that's going to help us answer the question, so we're going to leave it alone for now. This little a, that represents the initial amount, the starting point, the y-intercept. So in your word problem, what did you start with? We started with $500 in the savings account. The 1 plus stays the same. The R represents the rate, right? That's the growth or the decay. So do we have a growth or decay? What tells us that? The account pays, so you're getting paid 3.5% interest. That's growth on you. That's growth for you. So it's going to be growth. And because it's a percentage, we have to convert that into a decimal. 3.5% is 0.035 as a decimal. And T is time. How much money will be in the account after 5 years? So 5 is a time. Okay, now all we're going to do is just calculate everything. So again, this T is the same T, so it's just to keep track of time. So after 5 years, just use decimals. 500 times 1.035 to the power of 5. Oops. Power of 5. 593. So after 5 years, so the question was, how much money will be in the account after 5 years? $593.84. So this extra $93.84 was just paid by the bank free because of that interest that you got. So all you have to do is just type up your work. So A for the exponent, just do shift 6. And that little up arrow, that represents exponent, so it's perfectly fine. Just type up your work. And at the very end, just answer the question. How much money will be in the account after 5 years? After 5 years, there will be $593.84 in the account. And there you go. I hope this video is helpful, and I just want to let you guys know that you guys have been doing absolutely amazing. You guys are incredible. Thank you guys for working hard to continue your education, and we are almost at the end of this school year. I am very proud of you and appreciate every single one of you very much, and Ms. Vito Montes and I are always here for you, so please just reach out to us. Alright, thank you everybody. I'll talk to you guys later. Bye!